Hello, everybody. Welcome back to episode 9. You know the drill on the login. You'll need one, especially for the things that we're showing today. Last time, in episode 8, we were bringing in the power of the living atlas of the world. This is authoritative content. It's curated. There is good metadata on all of those items. And some of them, you need to be logged in, you need to be a subscriber of an ArcGIS Online organization in order to see it. Then we took a look at the Esri training site, Esri Academy, and the Esri Access enabled login, subscriber content, premium content, and the Learn ArcGIS site. Big session last time, and we have another huge one today. This is the analysis time. This is one where publishing privilege is needed all the way through the analysis that you will encounter. You need to have that publishing privilege. You're going to hear about this fellow John Snow and why this is such an important historic case. And we'll take a look at a series of analytical processes. It's a big day. It's a big episode. This is really key because this is why an ArcGIS Online organization brings such power to the web browser, things that everybody can do. All right, I'm going to turn it over to Joseph.
All right, folks. I, as Charlie indicated, am going to go through the fundamentals of spatial analysis with you all. And I think it's important. Reason why is because this is what really is the heart of geospatial technology. It really is. This distinguishes a GIS, a geographic information system, from a map. To be sure, those tools have their place. This is where the intelligence of GIS lies. Remember the G part of GIS, the map, the aerial photo, the satellite image, the 3D representation of the surface. That's the G part. The reason why spatial analysis works is because you've got the I part underneath the G. That's the tables. We've been showing you lots of different ways you can actually look at the tabular data, the table data, the information behind the map, or maps, as the case may be. And the reason why that all works is something called topology. These things have spatial relationships. That water well or that landfill knows where it is in relationship to surrounding land use, the surrounding watershed, etc. That's how all this works. In other words, one way you can approach it with your kids or with your students is that this isn't just a map floating around in cyberspace. All of these things have location. They have intelligence. So spatial thinking, my definition is identifying, analyzing, and understanding the location, scale, patterns, and trends of the geographic, so space, and temporal, time, relationships among data, could be phenomena, or issues. That's one definition. I'm sticking by it. And the Esri definition of spatial analysis, which is related, but the process of examining, very much related to spatial thinking, but the locations, attributes, and relationships of features in spatial data, right? Geographic data, through overlay and some other analytical techniques that we'll talk about today in order to address a question or to gain useful knowledge. I like to think of it as you're creating new information, you're creating new knowledge. You're not just regurgitating what already is there. You're actually creating something new, which is pretty exciting when you think about it. Think of it, though, folks, another way, and that is the fundamentals of it all, how we understand our world, our communities, our regions, our countries, our world. Mapping where things are is not the end goal. That's a tool to allow us to understand how things relate to each other and what does it all mean? And then, an action component. What actions should we take about litter in my community or water quality or whatever other issue that we're delving into? Now, I mentioned that poster. This is one of the graphics from one of the posters that we'll share. But the nice thing about these resources is that they really get into the hearts of spatial analysis techniques. And it's certainly the where. But we're looking at size and shape and distribution. Now, sometimes students don't have a vocabulary. What we'll do in the minutes that we have is to try to understand how you might approach vocalizing. So when you buffer, for example, that's one of the analysis techniques, a stream. What is it going to look like when you buffer it? 100 meters on each side of the stream. Getting even the students, if they say it's going to look like a puffy snake, well, that's okay. They're vocalizing what those patterns are going to look like afterwards. And how places are related, as I mentioned, finding locations and paths, the best paths to things. Okay, we'll do that, looking at patterns and also making prediction. What's it going to look like in my community if the population changes at this rate for the next 10 years, or if the water quality changes at this rate? So we want to make predictions. That's one of the things that people are doing out there in the workplace, right, with geospatial technology. They're planning for a more sustainable, happier, healthier future. This is another graphic from another poster that we'll share, again, helping you to make sense of what the components are of spatial analysis. I think one of the best ways to teach this stuff is actually to just guide you through a short workflow, a typical spatial analysis workflow. And this has to do with a certain workflow that is solving a problem of a natural hazard, a set of natural hazards actually in a county. So this is a place where there's a double hazard. There's a geologic hazard of potential landslides or mud flows, and there's another hazard of floods. Okay, so this is the scenario that we ask students to actually go through, and it's in ArcGIS Online, and it uses the tools that we'll walk you through in a moment. So these are the things that they do. They actually filter the floodplain layer. Then we actually buffer the floodplains. Then we dissolve these internal polygons. We'll talk about why that's important in a minute. And then we overlay different mapping information. We sort things, and we enrich the data with stuff that's up in ArcGIS Online. And for example, from the Living Atlas, you can actually stream data down to your analysis workflow. Okay, so first of all, we've got this data set, and you can recognize this is the ArcGIS Online interface. And so then we figure out how to reduce this set of polygons in a certain county, it's Boulder County, Colorado, to really the floodplain. So you've seen the filter tool. That's all we're doing in this step. And then we actually filter just all of the geologic hazards to the major ones. We only want the major ones. So now we've got a map of the floodplains and the major geologic hazards. And then we buffer the floodplains because we want to get a sense, floodplains, we're starting to exceed what we thought was the 100-year or the 500-year floodplain. And actually, this particular lesson I wrote before the 2013 flood here in Colorado, not too far from where I am. And it turned out that it was a real-world scenario. We've got a lot of communities around the world, right, that are in major flood zones. And a lot of these mountain front communities, for example, they were formed because they had access to the mountains through these canyons, because there was gold and then there are hills, right, and other minerals that people wanted to extract. And so you've got these communities that are in these really hazardous zones. So how do we deal with it? Well, GIS is one tool that helps us deal with it. And then what we do is we dissolve. All of these river segments, oftentimes in spatial data, are made up of different pieces, okay, like every kilometer or every mile. And so when you buffer those, they end up with a lot of different polygons. Every polygon is a 100-meter or 200-meter buffer around them. And so dissolving them makes all those internal lines between the polygons dissolve or go away. Then you intersect. This is one of the key fundamental tools that we use in GIS. So here, you're overlaying floodplains and geologic hazards, and you end up with a data set, a couple of polygons that have the double hazard, and then we enrich it. We bring data down. And what I do here is I have you enrich the data with data that is from the Census Bureau, specifically group quarters. Okay, so these are hazardous zones. We want to find out where nursing homes and hospitals and dormitories and apartment buildings are. In other words, where a lot of people are clustered in a short space. And then we select the largest of those polygons because, as you saw in the scenario, okay, you only have a certain budget and a certain time, so you've got to focus just on the largest polygon. So you do that, you sort the table, that's all that is. and then you calculate a route. You've got to go visit these sites. You've got to figure out what kind of public relations campaign you're going to mount to just make sure people are aware of these hazards. Now, this is a real-world scenario. When we had a 1976 flood in Big Thompson Canyon in Colorado, just north of this study area, that's, if you've been out west and you've seen those signs that say, climb to safety in case of a flash flood, that's exactly when those signs went up, is after that flood, because people weren't aware of the dangers, and they actually could have, a lot of lives could have been saved by people just moving up in elevation. So this is an actual real-world scenario. Now, I want to just make sure that you understood that my philosophy and those of my colleagues are, if you're doing something like in this web mapping application, one of our favorites called the Urban Observatory, you can compare about 40 different variables in about 100 different cities: median age, senior population, traffic, weather, land use patterns, etc. Is this spatial analysis? If you're not using the spatial analysis tools inside ArcGIS Online, for example, are you actually doing spatial analysis? We wanted to assure you all that yes, indeed, you are doing spatial analysis. There's lots of different ways to analyze and look at patterns, relationships, and trends. So you don't have to feel badly that maybe you're not using the analytical tools in ArcGIS Online with every lesson. That's okay. Remember, our philosophy is the most appropriate tool for the job. Your role as the instructor, and as parent instructors as well, is really critical here, folks. In other words, you're using these geographic information systems or GIS tools, right? The tools are just tools. They're enabling better understanding and decision making. And the tools also will do anything that you ask them to do, even if it doesn't make sense. So for example, if you divide or overlay tornadoes and mobile homes, those aren't the tornadoes that strike the mobile homes, okay? So you can divide apples by oranges. The point is, this is one of those key moments where your role as the instructor is important, because you're making sense of the data and you're framing the inquiry-based questions. And what we come down to is, this is the most important tool of all, right? Your brain. It's not the overlay or the buffer. Those are good tools too, but this is still the most important tool. And as my colleague Charlie often says, GIS is a thinker's tool. That's why it was created, and that's still why it's important 50-odd years after it was created. It's a thinker's tool is what it is. That's why we love it for use in instruction. Okay, so that's a little bit about what spatial analysis is and how it can be used in that flood geologic example that I showed. But now we're going to go into spatial analysis in ArcGIS Online, specifically using those analytical tools. And as Charlie indicated earlier, we're going to focus on the cholera investigation, London, 1854. Okay? All right, let's move on. One of the things that we wanted to remind you of is that if you're inside ArcGIS Online, as you see here, and you don't have an analysis tab, that means one of two things. Either you're not signed in, as is the case with me right here. You see in the upper right, it says sign in, or you're in an organizational account where you don't have publisher permissions, okay? All of these analytical tools, they create, remember I was saying they create new data. Now in this tab, as you can see right over here to the upper left northwest of the map is an analysis tab or portal to analysis tools. And here's a nice teaching technique that all of us have used, and we'd like to share this with you here in the next few moments. And that is, inside here, you've got 6 categories of spatial analysis functions. And this right here provides a nice way for you to introduce yourself or your students or your kids to what's in here. Okay, so summarizing data. See all these little I buttons here, these information buttons? These are, they're not too thin and they're not too thick. They're just right, okay? They're just right in terms of the length of them. They provide enough information to give you an idea of what each one of these categories of tools does. Inside each category is one or more tools that is under, for example, in this case, summarized data. So this is all about summarizing, calculating total counts, lengths, areas, and basic statistics, as you can see here in the description. In the following activity, for example, with the cholera epidemic, we're going to do a summarize within. calculate statistics for areas. We're going to calculate how many cholera deaths and cases were inside each buffer around a specific set of water pumps in the City of London. So this is a very nice, again, way of introducing yourself and also just kind of refamiliarizing yourself with what's in here. How do I know which tool to use? Oftentimes we hear from people saying, I didn't know that tool was there. Well, it's worthwhile to every so often go in here and see, oh, okay. Remember I said enriched layer when I enriched the floodplains and geologic hazards with the group, what the Census Bureau calls group quarters, and that is apartment buildings and nursing homes and such. That is where that tool is located. This is kind of the heart and soul right here. Hotspots, statistical differences, not just a density map and not just a heat map, but actual areas where a certain phenomenon is statistically different from another set of another area in that study site of yours. Proximity, we've already seen that in the floodplains lesson where you're creating a buffer around each stream, each river to get a sense of the floodplain. We've seen educators do this for calculating, what's a riparian zone, or in the case of the John Snow cholera activity, we're going to calculate buffers around each water pump. And again, some sort of a sense of here in this last category, classic overlay, intersection, union, all kinds of good stuff in here. Wow, I wish I could get excited about this. Anyway, those are some of the analysis tools that you can do. But remember, analysis takes place outside of these set of tools, but these are very powerful. And indeed, my colleagues and I got really excited when these analysis tools came in, because that really elevated ArcGIS Online, for example, from being a viewing tool to a real web geographic information systems tool where you could actually do analysis. Now, one last bit on this. In ArcGIS Online, as you can see here, there are 45-ish analytical tools. In ArcGIS Pro, there are 1,100 analysis tools. Okay, so use the most appropriate tool for the job. But there's enough here that keep you busy for quite a few semesters on into the future. All right, let's go into the map that you've probably seen in just about every geography and epidemiology book known to humankind, and that is the John Snow 1854 map. So what we've done here is we've actually put this inside ArcGIS Online. And this map is the map that John Snow made to try to figure out there's got to be some sort of spatial pattern to the cholera deaths. And these were very frightening, reoccurring episodes that appeared not just in London, but in many places throughout the world. The prevailing notion at the time was that there's some sort of bad air that causes people to get this nasty intestinal sickness that many of them die from. And so John Snow said, I've got to figure out if there's some sort of connection to maybe water. And if I can map that and then figure out where the water pumps are, maybe I can show the connection, and then maybe we can, remember the action part, maybe we can do something about it. Now, this map inside ArcGIS Online it's an image, right? As you can see over here on the left side, it is the John Snow map 1854 that I've got turned out. I can click on these little black spots that John Snow put on when he actually went house to house and found out what the fate of the victims were, if they lived or died, and where they were living, but I can't click on them, right? It's an image. So what we have here in this layer, I and others, there are many versions of this lesson, converted those black dots to a point. Remember, Kylie was working with you the other day on this, a point feature layer. A point feature layer. Now it has intelligence and it has a table behind it. I can actually click on these points and get the latitude and longitude, but more importantly, the number of cases at that spot. Now, why are there more than one case at each spot? Well, think about how people lived and still do today, right? You've got a spot on the Earth's surface, let's say an apartment building or a tenement, and it has multiple floors, as you can see here in this 19th century image of the UK. So you've got, it could be multiple floors, it could have multiple, sadly, it could have multiple victims on that spot. So how would we get a sense of that? Well, one way to get a sense of that, of course, is to change the symbology, the style, into some sort of like a heat map. Okay, now I can kind of get a sense of the pattern. It looks like there's a lot of cholera cases around this particular water pump here. But remember, we've got a GIS at your fingertips. You don't have to be stuck with kind of eyeballing things. Again, most appropriate tool for the job, that might be, if you're working with 10-year-olds, okay, that might be the end of lesson right there. Which pump do you think is the culprit? In other words, which one had the cholera pathogen in it? This could be the end of lesson right there, right? So, okay, but we can go deeper, right? I want to figure out, let's change this to, how about the number of cases? Okay, so I'm going to get a graduated symbol map, and now the bigger, there's a case, there's a point here that has 18 cases. And unfortunately, at this time, according to this data set, remember, I always have to say, according to this data set, cases actually means someone died. Unfortunately, that was the grim details. So there are pop-ups in here as well, but let's go into the analysis. That's really the focus here. I need to sign in because I don't have the analysis tools there. So I'm going to go ahead and sign in. And no, I don't want to save any of those changes. I'm good. All I've done is change the symbology, and I'm good to go. Okay, I've got a set of water pumps here. And what I'm going to do is go to the analysis tool, because my goal is to find out how many cases are within X distance of the water pumps. So there's a two-step operation. The first one is use proximity. So I'm going to expand that tool on the left, create buffers. Remember, if I don't know what that does, I can click on the identify button or the information button and say, oh, it's going to create a distance. And so again, getting the students to think about their vocabulary. What shape are these going to be once we buffer them? The shape of a river buffer was a fat, puffy snake, right? The shape of these is going to be, and all of you are saying, a circle. Charlie's saying circle. Yes, exactly. Because they're going to get a certain distance from each pump. So here's what's nice about these tools. They guide you through step by step. Unlike in the past where you kind of had to figure out, okay, what do I do first? What do I do second? Step one, what do you want to buffer? We want to buffer the water pumps. Step two, or zone two, if you will. What is the size? I'm going to do 500 feet. Okay. Okay, great. You've got some options. We're not going to go to any options. We're going to keep things simple. What is the name? Remember, the analysis tools, most of the time, create a new layer, and that's why you need to be creator in your ArcGIS Online organizational account. My layer name is I like to indicate to myself what the distance is. That way, when I come back to this later, I know right away from the name of the file, from the name of the layer, what I buffered. I could use the measure tool to verify, but I'd like to have it in the name. Okay, so buffer of public water pumps 500 feet. Save my result here. I could put it in a folder. Show credits. Ooh, so let's say you're buffering and you're overlaying and you're geocoding like we did the other day. How many credits am I consuming? If you need more information about credits, go back to that episode. Here I'm consuming a tiny fraction, a bite-sized, gluten-free little morsel of credits, so not much. I've only got 12 water pumps in here. And this last part here, though, use current map extent, that's an important thing to kind of keep in mind. Either A, you zoom out to your whole study areas in view, or B, you uncheck that box. The reason why that's there as a default, use current map extent, is because remember, this is online. So it's guarding you from geocoding every single Starbucks in North America. So I'm going to leave the current map extent on. That's fine. I'm going to run the analysis, and then it's going to create my buffers, correct, with the circles that, is it going to be the radius of 500 feet, or is it going to be the diameter of the circle at 500 feet? This is another thing I like to pose to the students as this is sort of cranking away. It's creating a new layer inside my organizational subscription, and when I go to my content, that layer is going to be there. And then, as you saw in previous episodes, I can share that layer with my colleagues, with my students. It's a beautiful thing. So what is your answer? Is that going to be the radius of 500 feet or the diameter? We can measure it to make sure, but in the interest of time, I won't. You know that it's the radius from each one of these points, each one of these water pumps, to the perimeter of that circle, that is 500 feet. because that's what I specified. Now, the distance that you buffer affects your results. So understand that, and that's another point of conversation with the students. Okay, so I've got a set of buffers now at 500 feet radius. And now the step 2, that was step 1. Step 2 is now I want to figure out how many points or cases are inside each one of those. Now, remember, do I have to do this? Let's turn off that analysis button for the moment. Let's turn on the waterborne cholera cases. I can actually use a tool that will count how many of those points, and as well as the number of deaths, inside each one of those circles. Now, that's not the end-all, be-all. We still have to use our brains, because did people travel to a different water pump? They didn't always use the closest one to their home, to their residence. They may have liked the taste. Step 2, analysis, summarize data. Remember I was indicating earlier, summarize within, okay? Choose an area layer. This is where a little bit of GIS vocabulary helps to summarize other features within its boundaries. What is my area layer? Well, it's my buffer. It only shows me 2 things. My buffer of the public water pumps, notice I saved it with the 500-foot part of the name. What I want to summarize is locations with 1 or more cholera deaths. That's my point layer for all of these cholera deaths, okay? Add statistics. Ooh, what about the number of cases? And maybe we could get a sum of the number of cases. That might be helpful. Okay, choose the field to group. We're going to keep it simple. We don't need to group anything right now. My resulting layer name. Sometimes these get a bit long. You are constrained to a certain width, a number of characters, but that's, for me, good. Summarize locations, I'm good with that. Remember this current map extent and the show credits? I'm going to uncheck that because I'm zoomed in a little bit, and I just want to make sure that it takes into account all of the points. And then I'm going to run analysis. Now, unlike the buffering, this summarize within isn't going to give us a new graphic layer, aside from a bunch of circles. But the important part of this part of the analysis is we're actually going to look at the table of data behind the new layer. And then we're going to be able to determine, with our GIS at our fingertips, what John Snow determined, 170 years ago almost, and that is that the Broad Street pump is the one where most people actually perished getting their water from. So therefore, perhaps there's this connection between water and cholera. Okay, so let's take a look at the new layer that we had. Summarize locations. Show table. Okay, remember we can sort these. I'm going to sort descending. This one right here, now you can see this cyan color where it's selected. I've got 12 features in here because I had 12 water pumps. This pump had 202 points, 202 locations, but 387 cases. The next one over here at Carnaby Street, which is a little bit off to the west-northwest, only had 58 points and 103 cases, okay? So what does that mean? It means that we've created a new layer, actually several new layers. We've come a little bit closer to the scenario in the lesson, which is now you're Jon Snow, and you've got to figure out what the situation here is, and then you've got to make your case. Communicating with spatial information, we've talked about that. You've got to communicate your case to the authorities, in this case in London. Some of you know the rest of the story. It wasn't like all of a sudden Jon Snow is a hero. It actually took a lot of tenacity. So what I like to talk about with the students here briefly at the end is that it took Parliament not being able to hold session because there was this big stink. It smelled so bad. Now that's a clue for why the water was tainted. Right? There was no public sanitation. So it dawned on them, oh my gosh, we can't be dumping our refuse into the water. Okay, we've got to have a sanitation system. Oh my gosh, there's 2 million people in London right now, and there's lots of other cities around the world with the same situation. We've got to do something about it. That actually gives me hope for the current crisis that we're in and other crises, past and present, that we can solve things. Admittedly, cholera is still a serious illness, and it hasn't been eradicated around the world. But for many people, because of analyses like this, they have a better present and a better tomorrow. So it's a very interesting, very much tied to spatial analysis. Now, the last part of the lesson, actually, there's a route that Jon Snow takes from his office to each one of the pumps to test the water quality. We didn't do that today, but that's just another function inside ArcGIS Online. That's a routing function. Can he get to all the pumps in 24 hours? We've got all these resources that we're going to share with you in the future. One last thing, though, and that is, this is a good indication that maps are not just reference documents. Maps are analytical tools. Now, for example, if you use the map of the Gettysburg Battle, okay, 1863, okay, you know where Gettysburg is. That's not the end of the story. If you're actually using that map, and there's one in ArcGIS Online, as you probably would imagine, that shows the position of the troops and the terrain and how all that interacted in the spatial temporal analysis, then you're using maps as an analytical set of tools. Not to put down where is, but the whys of where is what really is the heart of all of this. Thanks, folks.
Wow, Joseph, that was awesome. Tom, you want to kick us off with what's next?
Absolutely. Yeah, Kylie, why don't you go ahead and throw up the geo inquiry that we're going to use this block? You know, that idea of using multiple analysis tools back to back to help answer a question is really powerful. And the particular set of tools that Joseph used is a common one because it is so powerful. It's that combination of beginning by doing a buffer and then doing something like an aggregation of points within that buffer to really help tell you something about the phenomena you're addressing. So we wanted to bring your attention back to the level 1 U.S. History GeoInquiry. It's called Steel City. And this activity really looks at the Industrial Revolution in the United States. And of course, a lot of the American Industrial Revolution revolves around production of steel. So in the continuation of this activity at level 2, which I think Kylie may have somewhere handy, you'll note there's a 2 in the title bar. We actually examine the relationship, the geographic relationship between smelters and then coal mines that extract either coal or other resources from the ground and get them to the smelters. The interesting thing here is instead of looking at epidemiology, though, we're actually kind of looking at supply chain management. And oddly enough, it's kind of around the same time as John Snow. So Kylie, do you want to show us a bit about how we might be able to use that tandem analysis to make some sense of this?
Sure. First thing I did want to point out that I find really interesting with the geo-inquiries is how the level 1 and 2 build. So Tom talked a little bit about how we get into a bit more analysis in this level 2, but one of the things that I find really interesting as a parent teacher is that we use the same map. So you notice here the map URL is going to History GeoInquiry 8 because the steel one is number 8. If we look at the level 2, which isn't number 8, you'll notice that same URL. So I just wanted to point that out because one of the cool things with these level 2s is that they're going to build on what we've done in level 1. So you've built a base understanding of the map at this point, and now you get to do more with it. All right, I'm going to open the map now, and here you can see it. And there's no analysis tool. But like Joseph reminded you, a couple things to check, and the first one is if you're signed in. And you can see I'm not. So we're going to go ahead and get signed in. Great. Now I've got my analysis tool. So let's go ahead and look at the content. And some of this is things that the students will have done through the part 1 activity, and some are part 2. We're doing a little bit of both here, but that's okay. You have them both available and you can go through them as you need to. Now, one of the things I want to look at is the distribution of the resources we need from the coal mines and where those smelters are. So let's go ahead and we can turn on some coal mines, and we can turn on, wrong one. Let's see, we've already got the smelters on here, so that'll do for that. And the next thing I want to do is there is a buffer of smelters. Now, the smelters, we can double check, right? We're going to go ahead and click over here, and yep, we can see that's a smelter. If I wasn't sure which of the things on the map it was, I could also go ahead and take that layer and look at its legend. Yep, those red dots. So now I know what I'm looking for, and I want to see what's near them. As Joseph just talked about, near is a buffer. Let's create an area that we can focus on. Now, this is already done, and you can see the buffers. Well, that's great, but I'm kind of a curious person by nature. I don't want to just turn on the layer you showed me. I kind of want to know how you got there. So Joseph just showed us that buffer tool, right? And now I want to go ahead and do that for myself. So I remember, let's go ahead, and it was in the analysis tools. And right now, what are we doing again? Let me think about it. Okay, I'm trying to find out what is nearby, what has a close proximity, maybe. So now I could use the info buttons over here, as Joseph was showing, or I can remember, try one. Oh, here it is. So we can create a buffer. So I'm going to go ahead and click that, and I'm going to go ahead and pick that I would like to buffer smelters, as we talked about, right? That's the center point of these circles that I'm creating, is those red dots, or the smelters. So I picked that. And in this case, we want to look at what's within 50 miles. Now, with this, we talked about showing credits. And I'm going to go ahead and click that so we can see what it looks like. And it's pretty small, just like Joseph said. I'm going to give you a tip right now for when you're using a GeoInquiry. We have a claim in them, and I'm going to jump back on over. If you remember up at the top here, we talked about some of the requirements, and we've looked at this in other episodes. One of the things we say is approximately 1.3 credits will be used per person for this activity. Okay, great. When I'm over in this map, that credit number I saw, and we can go ahead and bring it up again, 0.06. Okay, that's definitely lower than that amount I expected. Now, one of the things you can use with that show credits button for is to kind of catch yourself making mistakes. What if I accidentally picked the coal mines? Now look how many more dots there are of coal mines compared to the smelters. And maybe I even forgot, like Joseph talked about, that use current map extent that's going to help limit what data we're sending to the tool. And I didn't have that one on. Now when I click show credits, I'm at 1.3. So that's bigger. It's not huge to where it would really notify me, but it might be enough in some of the other tools to help notify me that I have some settings wrong. All right. So let's go ahead and back to the correct layer. We're going to pick a smelter, 50 miles. Let's use our current map extent, and we'll go ahead and run that analysis. Now, like Joseph said, you can change the layer of that. And in this case, it probably would have been useful to add that 50 miles in there just to remind myself what measurement I did like he was doing. I think that's an awesome best practice or tip there. And we're going to go ahead and get these created. Now, in this case, as you know, I have these buffers already on the screen from the other analysis. So part of what I'm going to do here is actually a spatial analysis that's not through a tool. Like Joseph was saying, when we did visual analysis, that was still spatial analysis. So what I'm going to do now is I'm going to see my own buffers appear. Now, the default symbology is the same. So I'm going to come in here and change it just so I can more easily see the ones I made versus the ones that were made as part of that activity. Now, when I come back in, I can turn off my buffer and see the ones originally. I can turn mine on and turn off the others. So I'm going to go ahead and zoom out a little to show you those two layers. So let's turn them both back on. And you can see they're not an exact match, right? You can see the ones that turn purple. Well, that's because I might have had a different map extent. That's okay. I don't have to exactly match the lesson. My intent here is to get an understanding of how are we getting these buffers? What was done? And now I know. So the next thing I want to look at is why certain smelters were more successful than others. Okay, so now what I'm doing is I'm using these analysis tools to contribute to the knowledge that the student's gaining about a material or a topic that you're covering in class. Okay, so this time it's not about the disease, but like Tom was mentioning, it's about the supply chain and what's available where. Let's go ahead and turn off the buffers that were made for me because I'd like to use my own. And in this case, there's a bookmark I'm going to use to zoom myself back into the area that we're interested in. And I need to use another tool. All right, so to figure out how a smelter is going to be successful, one thing that's important is the transportation network available around it. And the other thing that's important is the materials available. So I have on this map some waterways. That's probably really key for that transportation. And I also have some mines in different places for those resources to come from. So right now I'm going to focus on the resource part of this. All right, you're going to find this very familiar, but we're going to go ahead and we want to look at what's close. Which ones are close. Now I've already created the buffers to figure out what area I care about. I've defined my close, right? To my close is that 50-mile buffer. So I have those polygons or circles that define close. And now I need to know how many things are in there. So like Joseph did, I'm going to find a summary of that's going to be important. And this aggregate points tool is what I'm going to need. So I can again remind myself, okay, yep, take a bunch of little points. Let's make it one big point to get that information summarized for me. Again, I could do this visually and counting on the map, but since I have the tools in this case, aggregate points is going to be better than me counting. Now, I don't really care how many cities are close, although that might be important at a later part of my analysis. Right now, I want to look at how many coal mines. So right now, you have to think a little bit about this. Okay, I need to choose what I'm aggregating. So I think of it as what little dots need to turn into a big dot. And that's the item I'm picking here. Okay, so I want the little dots in this option, and that's the coal mines. And down here, what's the aggregation area? Okay, so where do I care about? Where do I want to know? What area do I want those little dots to turn into one dot for? And we just made that buffer, right? And you can see there are both here. I'm going to pick the one I made. All right, so really, from that, I can get a count of how many coal mines are close. But like Joseph found, there is more information. And since I don't have to do this visually, I want to add in some more. We have a field of total production. That's how much production each of these coal mines had. Let's sum that up, because it doesn't only matter how close a coal mine is. If that mine doesn't produce anything, it's not actually going to be very helpful for that smelter. So go ahead and add that statistic. Like Joseph, that's good enough for today. We're going to go down, and again, before I click Run Analysis, I want to click Show Credits. I just want to give that little extra check for myself to make sure I haven't done something silly. Okay, it's a pretty small number. I don't need to worry about it this time. That seems reasonable. Go ahead and we'll run the analysis. Now, like Joseph said, as I'm running this, I'm going to be taking this data and this visual analysis I could have done, but instead letting the tools do some of it for me. It does take a minute to run, but that's okay. Let the students think through what they've just done. What are they going to get? So, okay, as a student, I might start thinking about, okay, I'm going to get points. And these points are going to have two pieces of information, right? I'm going to know how many things were close and how much they produce. So let's think back some episodes, something we learned about symbology. Do I have to pick one variable? Do I have to pick one field and use only that? No, so we looked at how you can symbolize on two things. And in fact, that's what I'm going to use here, to take these single points that are created and now are appearing for us and really focus on it. So I'm going to turn off some things right now. I'm going to go ahead and turn off my buffer because I don't need that right now. And let's see here. All right, so I've got my smelters. Let's see, okay, so that's what's drawing right now. That's my aggregation. All right. Let's look at the symbology used on it. Right now, we have a dot showing a count of points. Okay, that's useful. This is how many mines are within that area. But remember, we also added some other information, and that was a sum of the total production. So I can add that in as well. And like you saw in the other episode, one of these features is using, or one of these attributes is going to be using the size, and the other one is using some color. Cool. All right, so now when I look at my map, let's go ahead and use that. Let's focus in a little bit here. So I can see these smelters, well, they're a little hard to see. Anyone remember how to make them easier to see when I've put other things on top? All right, well, remember that the order matters, right? The order that things are listed is how they're going to draw. And so my smelters are now underneath all this other information. So I can drag those right up to the top, oops, and make them easier to see. It just makes it easier on my eyes, right? So now I can see them right on top. And I can get a look at, even though this one here, the color, or sorry, the size, and this one here, they're fairly close in size, right? But is this one as productive as this one? What do you think? The raw materials available here have a lower total than the raw materials available here. So even though they have the same number of mines, the mines at this smelter up here were much more productive, which in turn can make that smelter much more successful. All right, if you want to run through some of this on your own, remember they are the geo inquiries. We'll have links for those with this episode later, and you'll be able to go ahead and go through the full steps and do some analysis on your own. Tom, what else did you want to say about this one?
One word of warning: when you're building your analysis, the layer name that the computer gives you needs to be unique, at least unique for
right.
the application. So sometimes it helps to put your initials or some other string in front of that layer name so that you don't end up with an error based on the layer name. I think with Charlie in the next block here, we can take a closer look at that though. This is great.
All right, thanks.
Thank you. So I think at this point, we're going to go ahead and reshare with Charlie now, and we're going to take a look at some rivers and watershed analysis. Here you are. So
I'm ready.
We're going to start by taking a look at the Earth Science GeoInquiry collection. And like Kylie's example, there's a level 1 and a level 2 activity. And I think we're going to jump straight to the level 2 activity in the interest of time. This is the rivers, the watershed activity that he's loaded up now. Now the activity, if you follow the script as it's listed out, really looks at the cities as they fall in a watershed. And so you can use some of those analysis tools to determine how many cities, for example, fall into a particular watershed. I think today, Charlie, don't you have a little bit of a spin on what we're going to do with this same data?
Of course. So I was looking through this and I said, this is really cool. What's really nice is that it focuses on the major watershed in which I live. Now, I live in one of these watersheds right now, but I grew up in one special one, and I grew up as a kid with a favorite fishing hole. It was on a river, and every spring, the river would flood. And so I just got used to it that way. It never dawned on me why the river might flood the way it did. And so if I just zoom in to my favorite fishing hole, it was a place on the St. Croix River between Minnesota and Wisconsin. And the whole notion there of, hey, here I am on that river, and it never dawned on me, like, where's the river going? And so what I would like to do is do a trace downstream to see where it's going and where does it end up? And then turn around and look upstream and see where's it coming from. Does that sound okay? All right. All right. So I got my fishing hole here. I want to go to the analysis zone. And another way of thinking about that is if I look at my fishing hole and it's just a map note, and the only thing that I've got attached to it is my analysis tool. What am I doing here? What I need to do is to figure out where is this going? And I could look down the list and say, no, it's not summarized. Find locations. Ooh, trace downstream. That's what I want to do. Trace downstream. Now, because I began with my fishing hole, that's the one that it's working with right now. Trace downstream. I can split it if I want to. I can do a variety of sort of explorations. I want to see it go all the way down. So what am I going to call this? I'm going to call this my fishing hole trace. I'll save it in there. I don't want to use the current map extent because I want to see where it goes. So I'm going to go ahead and click Run Analysis. Ooh, the resulting layer name contains an invalid character. So I need to come back here and take out that little extra character there. So now, how about this? Ooh, contains one or more. So I'm just gonna, oh, there's another one that I didn't take out. Charlie's fishing hole trace. All right. Ooh, now one of my friends, Catherine, told me a trick. I see this magic spinning wheel up here, and if you see that spinning wheel going, it's working. And it only works when it says, I got everything in operation here, I'm doing my thing. And as long as that little spinning wheel is going, it's thinking. And so what I should end up, following that guideline that Kylie gave us, what should we end up with here? I should think about this. This is going to be coming up with I'm following, where's it going? Should be coming up with a line. And well, what have I got here? Is there a new line here? Wait a minute, there's a new layer here. Not just a map note, this is a whole new layer. This is feature data. And I'm just going to say zoom to it. wow, I need to zoom back one to see. It goes from my fishing hole all the way down to the Gulf of Mexico. That's where the water is heading.
Charlie, can you flash the Huck boundaries for us so we can see it?
Can I flash the Huck boundaries for you so that if I go back and see that, let me zoom to it again. Zoom back one notch. So there's that hydrologic unit code. That's the...
And can you toggle that layer on and off for us so we can just get a better understanding of what that drew out?
Here's my watershed.
Ah, very cool.
Yeah. I might need to use the Kylie trick of changing the color to what I used to call Magneta or something like that. But now let me go back in and turn around and see where's it coming from. And for me, it was this notion of saying, I didn't really understand a watershed, but now I see my fishing hole still. I want to see where's that water coming from. Now with my GIS here, I can see that there's a watershed boundary that I should be paying attention to. But as a kid, all I knew was upstream and downstream, and there was no end to any of that. There was no boundaries anywhere. So let's go in and look. I'm going to, one more time, I'm going to click on my fishing hole. And where did I see the trace? It wasn't summarized. I think it was in the find location. There we go. Create a watershed. Is that what I want? Yep. The dot, the landform. Yep, that's where it's coming from. All right. Let's do it. Charlie's fishing hole point. Search the distance to the nearest drainage. So if I had been on a stream that was 100 yards from the river, then it would be following the stream up there. If I were 10 yards from the river, it's going to say, hey, do you want me to just go to the river and follow that? And that might be a sensible thing. But I know that I'm right on the river, so I'll just take it where it is. And now I'm just going to call this Charlie's watershed. I got to remember to take that apostrophe out. And I'm going to say, use as much of the area as you need to figure out where it's going to be. My fishing hole, turn around and show me all the area that this is. All right, I got the magic wheel spinning. So I know that this is working. So this is like thinking about what's going to be feeding the spot on the river where I think of my fishing hole. And in the springtime, it might rise 20 feet above where I would be fishing. And it was maybe 75 yards across. Ooh, wow. Look at that. What did I get? I got my watershed here. Let me turn that on and off and see that I got, wow. So if I click on this, that tells me there's my watershed. There's my fishing hole, 6,200 miles. Now there's this funny little chunk in here, 6,200 square miles, except here is an area that is sort of like a little dish. It's a little bowl that doesn't have streams flowing out of it. It's like a little dish that is in by itself. But the rest of it, that's a big area. And so when that area in the wintertime would get a lot of snow, and in the springtime we get a heavy spring rain, all of that stuff is going to drain right past where I am. So no wonder the water would rise way up like that. Hey, Tom, this is a really cool lesson.
It is. And it gives you a lot of opportunity for investigating your own questions with related data and analysis tools.
Yeah, I like that. That's the earth science watershed analysis, the level 2 process.
Now, if teachers or parents are going to do this at home, one thing Kylie pointed out is you should always check the amount of credits that one of these analysis tools is going to burn when you do it. And I think Charlie had maybe done this exercise once or twice and knew exactly how many credits he was burning. But as a safety precaution at home, you should always check it. It'll just make sure that you're doing exactly what you think you're doing. But this is an extremely cool map. And Charlie, I hope that you share this map as it is right here with the mapping hour group.
Cool. All right. I'm going to save, since it's the my project, I'm going to save this. And I'll share that with the mapping hour group so that everyone can see it. These layers that were created. Remember, I created these layers. There's my fishing hole trace and the watershed. They need to be shared as well. So this is the part of the magic of sharing that process. It's going to say, you want to update those layers, make sure they're shared as well. Yep, we're going to do that.
Cool. That's great.
All right. I gotta make sure that they're shared. All right, done. Okay, and let's see if we can review. Publishing is so important because you need to do that in order to analyze. Each time you're doing some analysis, you're generating data. So you got to have that publishing capacity. Did you like that story of Jon Snow? Wow, terrible situation, but what a mind to come up with. I think there's a relationship here. Something about these different layers and all of these different analytic processes. The concepts and skills in this one are really easy to describe, but they take time to work your way through. There's about 30 different items within these different analytics. And then as you work your way through, what I like to do, because I really forget a lot, I click on these things and take a look at the graphics and take a look at the summaries of each of the individual items. And after a while, you'll get comfortable with all of them. Some resources. Okay, first, the GeoInquiries, go for the level 2. And then again, if you don't have a login that gives you the right permissions, just make sure that you go back to the Mapping Hour hub site and do the survey and request the login. We took a look in episode 8 at some of these places that teach with GIS. If you go in under the capabilities and choose spatial analysis and data science within that, you're going to get a whole bunch of results. A lot of the activities spend a little bit of time doing analysis and then some of the time doing the presentation part. Focus on doing the analytics from one lesson, then another. Really work on the analysis side there. The same thing is true with the Learn site. They'll walk you through a little bit of analysis and then go to some other parts. Now, just focus on the analytics to really nail down the spatial analysis and data science. You'll also see at the training site, if you click on the analytics button and then click on getting started and then click ArcGIS Online and click the free checkbox, you'll get a handful of results and you can go through and pick, because some of them are multiple items just in and of themselves. Go through and look at those. But you'll see this whole set of all of these new capacities here. This is what GIS is all about. Looking at the patterns and the relationships of all of these different layers of information. That's what makes GIS so powerful. So much more than a map by itself is cool. But when you're using, as Joseph mentioned, GIS as a problem-solving tool, and yes, a tool for thinkers, it's what allows us to make the world a better place, to make good decisions. That's been a great hour. Thanks, everyone. Bye-bye.
Bye.